Hello, teachers, and welcome to the new year. Boy, 2017 has already started with a bang, and we just wanted to give you a quick take on some of the new and really interesting happenings within our COPs. At the end, we'll be also going over the solutions to the newest math fixes, so stick around. The participation and postings within the grade level COPs has really begun to pick up. We are seeing so many more teachers reaching out for discussions, and resources, and support around this year's CCRSM work. There have been some discussions around pacing within units and modules, sharing of some wonderful resources found and teacher-made, and even a few examples of classroom discussions. I highly encourage you to go deeper within your COP to get involved in these discussions or even start one of your own within this next week. We are once again looking for some share-outs and shout-outs in our monthly happy hour. Please think about these amazing and positive events you are seeing in the classrooms and post about them when you see this logo. And now, without further ado, it's time for the solutions to this week's math fix. Now we're going to take a look at this week's 8th grade math fix. We are working with the standard 8.ed.5, and it deals with comparing two different proportional rates, often represented in two different ways. With this problem, we start off with having two students who are mowing lawns and earning a bit of money for that work. Student A has a nice graph representing their pay per hour, and then we are given a per yard rate for student B's work. We must evaluate what is the slowest pace student B can work at and still make more money per hour than student A. According to the graph, student A makes $6 an hour. Student B, however, gets $15 per lawn. We next see that if we worked 6 times some number of hours and get $15, then our rate must be 2.5 hours for that $15. So if student B can mow a lawn in less than 2.5 hours, they will maintain a rate of earning money faster than student A. Another possible way of getting the solution to this problem is to look at the graph and see where $15 earning and see what equivalent number of hours that is. It's a little more difficult given the detail of our graph. So I would encourage you to get your students to think about these in numerical rates rather than graphical representations. Now the flipping between the rate per hour and the rate per lawn is challenging, but it's a practical for students. They can look at the merits of working for job completion versus per hour. It has applications in real world, how the two different focuses influence a worker's motivation. Student A is happiest when going slow, getting the most hours and really doing the fewest lawns. But student B needs to be going fast, working the fewest hours and getting the most lawns done as quick as possible. As always, we'd love to hear how you and your students are engaging with this math fix, so please share with us your thoughts and experiences or even student work, and those likes and feedbacks about those events going on in the COPs are always welcome.